Hello guys and welcome back. My name is Shruti Khandelwal and today we are going to study the solution of theory of computation's first internal, which is based on automata theory. Let us look at the questions. The first question is, construct a finite automata to accept the set L of all the strings over 0, 1, 0 that are of the alphabet 0 and 1. So, as we know, a finite automata is a 5-tuple. It consists of 5 things, that is Q, which is a finite set of states, sigma, which is the set of alphabets which constitute the language, delta, which is the state transition function, Q0, which is the start symbol, and F, which is the set of final states. To accept this, we have a state transition table as well as a transition graph which shows how this finite automata progresses. As we can see, when we have 0 at Q0, we can either stay at Q0 or move at Q1. Since this function lacks exclusivity, we can determine that this finite automata is non-deterministic in nature. And also, when we have 1 at Q0, we can stay at Q0. At Q1, if we have 1, we can move on to Q2, or if we have 0, we move on to the reject state. At Q2, if we have 0, then we move on to Q3, which indicates that this finite automata accepts all the strings that end with 0, 1, 0. And if we have 1 at Q2, it goes to reject state again. At Q3, anything that occurs either goes to Q0 or goes to the reject state. This indicates that this is a finite automata that accepts all the strings that end with 0, 1, 0. Finite automata can also be expressed using regular expression. Hence, finite automata also accepts all the regular languages. Let us look at the code for this question. Okay. We have a public class finite automata which defines 4 states, Q0, Q1, Q2 and Q reject state. It accepts a string, that is accept string, which accepts the string input and denotes the current state as Q0, which is the default state since it is the start state, and the current state is indicate Q2 because it's the final state. Now we have a private static in transition, another function which is transition, which defines the current state, which either was Q0 or Q2, depends upon your disposition, as well as a char symbol. Now, if what depends on the current stage, we use the switch case. At Q0, if we have 0, we move on to Q. We stay at Q0 or move on to Q1, and if neither, then we have the reject state. Since it only accepts 0 and 1, since the alphabet of this language is 0 and 1. At Q1, if we have 0, we move on to the reject state, since it accepts 0, 1, 0. At Q0, we have Q reject state, and at default, we also have Q reject state. Since if the state is invalid, we already move on to the reject state. In the main string, we define 3 input functions, that is 0, 1, 0. Since it already ends with 0, 1, 0, it is accepted by the finite automata. Then 0, 0, 1, 0, 1, 0 is also returns true, and 1, 1, 1, 0, 0, 0 also returns false.